Hey there, welcome back to stm32 coding for everyone. In the previous tutorial, we saw how we could set up multiple stm32 hardware timer to basically handle different events by calling the timer overflow callback function. Now in this tutorial, we're going to see how you can achieve the same result by using only one timer. Okay, so to do that, let's go ahead and clear our pin out. As always, we're going to clear everything and start from scratch. Now head on to the system clock and we're going to enable the serial debugger, basically the serial wire, and let's go ahead and click on the RCC register. Now on the RCC register, as always, we're going to bypass the clock on the high-speed clock and we're going to choose a crystal ceramic resonator. Great. So this is the usual stuff that we do when we start project from scratch. Then we're going to select our timer here. Now you can choose any timer you want. We already know the frequencies in which these timers are running as we saw on the previous tutorial. So I'm going to go ahead and select timer 3. Okay, then we're going to enable the internal clock source for this timer. Okay, now we're going to set up our prescaler to 64,000 and our counter period we're going to set up to 1000. Great. And we're also going to enable the auto reload preload. Then on the trigger event here, we're also going to update the event. Now the next thing here is to basically set up your channel. You need to enable your channel for the output compare. So that is the functionality that we're going to be taking advantage of. So once these settings are done, let's go ahead and enable our channel here and we're going to choose output compare channel 1, and automatically you can see PS6 have been selected, and on channel 2 let's go ahead and enable that is enabled, and channel 4. Great. Now remember, unlike on the previous tutorial where we had multiple timers, okay, this time around it's only one timer. Now we're going to set up the counter overflow for all these channels. That is why we're selecting channels that are now connected to specific pins on our microcontroller. Now this is important if you want to control some external devices like a relay, a buzzer, an LED, a motor, or whatever you want to control using your microcontroller pins, and you want to set them to run for specific time period. Without writing a lot of code, you can basically set up your timer to drive the output compare mode to basically toggle all your pins in a very sequential way. So now the first thing we're going to do here is to basically set up things here, because things must be set up here. Now those pins here, it must be the pins where you've got things connected. Now right now, the way my LEDs are configured, I've got on PS6, PS7, and PB0 and PB1. So what I'm going to do, I'm going to switch these PA4 LEDs here. Okay, so I'm going to select PS7 and I'm going to set timer 3 channel 2 on PS7. Okay, great. As you can see, and channel 1 move to PS6. So that means I am all set and my LEDs are all going to be toggling. Great. So if you don't have extra LEDs, you have to make a plan, because on the Nucleo board you only have one LED, so you won't be able to test this code using the Nucleo board. Only you need an external device that will give you some other LEDs. Now if you don't have external LEDs, remember you can also use the counter variable overflow incrementation like we've done on the previous tutorial. Great. So let's go ahead and basically set up here. So what we're going to do, the first thing here is the mode here, we're going to change and toggle on match. So when the variable, the overflow variable match, that when we need to toggle. So that's what the function means. So we're going to change here and set it to 1000. So that will be 1 second. And the output compare preload, we must enable it. Now the polarity is set to high. Okay, so we can change it to low if you want it to toggle a low. So we set it to a high, and we're going to go ahead and do the same thing on all the 4 channels. And this one is going to be 750, and we're going to enable the next one, toggle on match. Make sure you've got the settings all exactly the same. This is going to be 500 milliseconds. Then let's go ahead and do the last one, and this is going to be 250 millisecond, and we need to enable this as well. Great. So now if everything is set correctly, we can go ahead and generate our code right now. So click on code generations and stay back and take a cup of coffee and wait for your code to complete. Now, once the code generation is completed, let's go ahead and observe and inspect our code here. We can see that we've got the usual initialization and the timer variable for timer 1. Okay, that's the only one. We've got the system clock is set up and our timer 3 initialization. Now, this is where we've got all the if statement here to basically turn each one of the channel at a specific timer overflow. You can see the 1000, that's a 1 second, 750 millisecond, 500, and so on and so forth. Great. Now, before we can upload this code, we need to basically start the timer. Not only start the timer, but we need to start the timer output compare on each one of the channel. That is very important. So as always, we're going to find the drivers and open the timer source code, and let's go ahead and open this function. And once that file open, click on Control F and go ahead and paste these functions. So that is the HAL time underscore OC underscore start. So that's a timer output compare start. So I'm going to go ahead and click on find, and we need to find it wherever it is hiding. It is this function here. Now you can see that we're going to pass the timer variable and we're going to pass the channel name. So let's go ahead and copy this whole line of code and go onto the main function here. And right after the initialization, that's where we need to put it. So we can go ahead and pass the channel number. So that is channel 3, and we need to reference it as well. Great. So that's what we need to do there. Now, this part here is the 32-bit variable for the channel name. Okay, so that is going to be called TIM underscore channel underscore 1. Now this is for channel 1, and we need to do this for all the channels. So let's go ahead and copy and paste all this line of code, and then just change channel 2, channel 3, and channel 4. Great. So basically we are ready to compile this code. There is nothing else we need to put here. If everything is done correctly, our code should execute without any problem. So I'm going to go ahead and build. The build is completed, no error reported or warning. So everything is going very well. So we can go ahead and click on run to basically load this code. Okay, click on OK. Make sure that we basically loading the timer output compare program, not any other program. So if it was a correct one that was loaded, we should be having LED toggling. There we go. As you can see, we're starting here. Okay, and it is repeating every time. So you can change the time if you wish. Okay, so basically this is overflowing based on your prescaler here. You've got a prescaler of 64,000. So remember, this timer is running at a 64 megahertz frequency. So you can do your calculations and execute and set up wherever you want. You can set up a relay to toggle every 2 minutes. You can set up a buzzer to sound an alarm, or whatever you want to run. This is how you can do it, just by running a timer without running a lot of code. So that is it, guys, for this tutorial. I hope you found it useful. If it was useful indeed, please give it a thumbs up and subscribe to CMTEQ channel. Until next time, cheers.